Hi everyone, so here's the Moments Challenge question from today's lesson. And we're going to go through this as with other questions. We'll draw a diagram together and then we'll have a look at working through this. And part A of this should be pretty straightforward. So part A of this question is not the challenge part of this question, but let's work through part A to make sure we're happy with this. So let's get the situation drawn. We've got a log of length 10, so a log AB of length 10 metres, so let's get that on so we can use that to reference our different distances. It's placed on two smooth supports. C is 1 metre from A, so this isn't to scale, but let's just sketch that on there, and that's 1 metre distance, and D is 2 metres from B, so again let's just get that on there approximately. There's 2 metres from D. And it says when a force of 600 newtons is applied vertically upwards at A, so 600 newtons acting upwards at this point, the log is on the point of tilting about D. So when that happens, the log's about to tilt. We looked at this in yesterday's lesson. The log's about to tilt at this point. So that's going to mean at that point, as it's just about to come off, the reaction at C will have gone to 0. And then after that, if it carries on, it's going to carry on tilting. But as it's just on the point of tilting, it's still in equilibrium in this situation. So the moments total is going to be 0. Let's put our reaction forces on then. So we've got a reaction at D, and we've got a reaction at C. And because we're at the point of tilting about D, it's about to lift off the pivot point C, the support at C. So that reaction at C is going to go to 0. Okay. So that's our situation drawn. Let's have a read. It says initially, so to begin with, we think that this log can be modelled as a uniform rod. We think the weight is equally dispersed, so we can have that acting nice and symmetrically at the centre. So that's our assumption to start this question off. Let's just put some other measurements on. If that's 10, that's 5. So this is going to be 3. That's 10, that's 1. This is going to be 4. So I'm just putting them on so that when I do my moments, I've got them on clearly on my diagram. Okay, calculate the weight of the log. So let's tell the examiner what we're doing. I'm going to take moments about D because our C, it's about to tilt there, that's going to go to 0. This is where the thing's turning about. And if I take moments at D, I don't need to worry about this reaction force RD. So taking moments about point D, and I'm going to tell the examiner, as always, I'm going to take clockwise as positive. So let's have a look at what's happening. So this 600 is going to be pulling and tending to turn clockwise around D. And the weight then is tend to be going this way, so tend to be turning anti-clockwise. So my 600 positive moment effect, my distance from D, this perpendicular distance, so if this is 2, this is 8. And then W, my weight, is tending to turn this thing anti-clockwise, so minus W, and my perpendicular distance from D is 3. And the sum of my moments is 0 because it isn't tilting yet. It's about to tilt on the point of tilting, but it's still sat horizontal, so that's where that 0 comes from. So 4,800 is 3W, W is 1,600 newtons. So there's our estimate of the weight if we're assuming that this thing is a uniform rod. Okay, and here's now the challenge part of this question. So now it says the force A is now removed. Sorry, the force at A is now removed, and a different force of 750 is now going to be applied at B vertically upwards again. And the log now in that instance, this has gone, force here is about to move about C. And now it tells us here, you can see I've underlined this already, remodel now, so have another go, but this time actually we've realised that this is not a uniform log at all. So it's not nice and uniform. So we're going to treat it as a non-uniform rod. We can't have the weight acting in the centre anymore. Okay, so let's redraw this then. Let's have a look. Part B, we're going to redraw it because I need to put my weight not in the centre anymore. And also I need to take that force off and put a force of 750 at B. So let me draw that again. So it's the same log, don't forget. It's not a new question. It's not a new log. It's the same log. We're just changing our modelling assumption from being in the centre here to being somewhere else. So what have we got? We've got our support is still at C, 1 metre away from A, and our support is still at D, 2 metres away from B. But this time it's a non-uniform log, so this time I'm going to put my weight on, excuse me, somewhere else, not in the centre. So let's put my weight there, and I'm just going to call this distance, doesn't matter which way you go, but I'm just going to call that distance there X, because that's going to be involved in my perpendicular distances in this question. Okay, so what else have we got? We've got our reaction force at C, we've got our reaction force at D, and now in this new situation, I've got the force has been removed from there, removed from there, and now the force is here, 750. Okay, and my full distance is still my 10 metres. There, this is still 1, this is still 2, this is X. Okay, so now let's have a look at this. It tells us in the question now, the logs now, when this is moved from here, 600 taken off, 700 moving upwards here, it now is on the point of tilting about C this time. So we're about to tilt here. So that means this reaction force is reduced to 0. Okay, so let's take moments here then about point C, because then I don't need to worry about this variable. This has gone to 0, and I'm about to turn about this point anyway, so that seems logical place to take moments. So moments about point C. Keep telling the examiner clockwise is positive in all of this. And if I have a look at this then now, W, if I'm taking point C, is trying to turn me clockwise, so that's positive. And my distance from C is X. My reaction force D is 0, so I don't need to worry about that. The 750 then is pulling upwards, so that's tending this system to tend to turn anti-clockwise, so minus 750. And my distance is then this distance here, this whole distance here to C. Well, if this is 1, that whole distance is going to be 9. And that must be 0 because it's not actually turning, it's all still in equilibrium. So WX is equal to 6,750. So I've got 2 unknowns here, 2 variables, so I need another equation. Okay. And when we've done this, we've seen before, quite often it's quite good to take vertical. So I'm going to look at that in this question. What actually happens is it doesn't work out, but let's have a look at why. So let's try that, because that's what I would have tried initially. So let's do that. So let's look vertically. What's happening? Well, vertically, RC, that's nothing, plus 750 upwards, and then downwards is just this weight acting downwards. And this is okay, this is mathematically correct, but I've got a different unknown now in there. So I've got my W, which might be of some help, but now I've got this new unknown on there. Well, let's see if I could take maybe moments about somewhere else, because we've said before in these questions, you can take moments about wherever you like. So let's take moments about somewhere else and see if we can try and get 3 equations and 3 unknowns and sort that out. Okay, so point A is as good a point as any, so let's take moments about A. Clockwise, positive. So about A then, let's have a look. We're going to have clockwise just this W downwards, and that distance is going to be 1 plus X. Then this reaction force is going to be tending to have an anti-clockwise moment, and that distance from point A is 1. What else? We've got this 750 again, tending anti-clockwise, so minus 750, and that's the full 10 metres away from point A. So if I sort this out, I've got W plus WX minus the reaction at C minus 7,500 is 0. That's fair enough. Then this WX, well, you know, I've got that from over here, so let's sub that in, because WX I know is 650. Great, so we're getting rid of the variable X in this one. But now if we look at this, what's actually happened now, if, excuse me, I take these things over, keep W as the subject here to try and do something here. If I take W over, then what's actually going to happen is I'm going to get 750 on this side plus reaction at C. So all that's happened is I've just got a repeat of the same equation. So there isn't enough there to help me do this question. So what am I going to do? Well, basically what we've got to remind ourselves about is that this is the same log as this was in question 1, for this situation, we haven't changed the log, we've just changed our assumption. So actually, I need to redo this one, because this is not true anymore if I'm taking it as non-uniform. So I need to redo this situation, but with W acting not at the centre. Okay, so acting somewhere else. So I'm just going to move this piece of paper up a little bit, and we're going to have a look at doing that, and then hopefully we'll be able to come back and look at this. So I'll use this bit of space here, I think, and then I've got another sheet of paper underneath we can move on to when I start running out of space. So let's do that. So this was, mathematically this is correct. It just hasn't helped us to get another equation to solve for these two unknowns. Okay, so what am I going to do? I'm going to remodel the situation from the first part of the question. So I'm going to remodel the situation from the first part of the question, but now with a non-uniform log. So basically this situation, but with W acting here. So let's have a little look at doing that. So this situation now, this first situation, but with W not at the centre anymore. So I've still got, my support C, I've still got my support D. This distance is still this X, this unknown distance that I don't know. And I might put W in the wrong place there, but it doesn't matter because we could always work out X in the question if we wanted to. I've got my reaction at C acting upwards. I've got my reaction at D. And in the first part of the question, we've got this 600 acting upwards at A, 600 newtons there. And what happened there, it was at the point of tilting about D there, okay? And this whole thing is my 10 metres. So now it's a point of tilting about D, so the reaction at C is 0. So let's take moments about point D, just like we did here, moments about point D. Let's see what's going to happen there. I'm going to get moments about D. So RD, that reaction, is having no turning effect at all, so the moment's 0. RC is 0 because it's about to tilt about point D. So my 600 is going to tend to turn me clockwise. And that distance from D is this whole distance. So if the whole lot's 10, this is 2. That distance is 8. And then, what else? Then my W, my weight, is acting down here, so tending to turn this thing anti-clockwise. And then I want the perpendicular distance of W from D, so I want this distance here. So let's have a look at that. Well, that's going to be, if the whole thing's 10, 1 and 2, so that's going to be 7 minus X. Okay, so that's going to be the 10 minus the 2 minus the 1 minus the X is going to give us that distance. And that's going to give me 0. So 4,800. Taking this over is 7W plus minus WX. So that's what we've got now. And now I've got two equations that I can use because now I've got two equations in the same two unknowns with W and X. So I'm just going to get a new piece of paper, having a look at those. So we've got 4,800, 7W minus WX. And we've also got from the first part of part B, WX is equal to 6,750. So I could get X on its own, let's say. X equals 6,750 over W sub in, or I can just go WX is in there, so let's sub that in there. So that's going to give me 4,800, 7W minus 6,750, 1,550 is 7W, so W is going to be 1,650 newtons. So that's my revised estimate for the weight of the log if I've now refined my model and instead of taking it as a uniform log, as we did in the first bit of the question to get this weight, I'm now assuming it's non-uniform, remodelling the whole situation, so this first situation and this second situation, and I've come out with this new estimate, 1,650 newtons.